This video is going to examine the notion of line reflections, or in other words, what an object looks like after it's been reflected over a line. So that's exactly what a line reflection is. A line reflection is simply a transformation that flips an object over what we call the line of reflection. Now, the line reflection, unlike the translation that we've looked at so far, is an opposite isometry. Opposite meaning that the orientation is reversed, isometry meaning that the size remains the same. So again, this whole notion of opposite means that orientation is reversed. So the orientation is reversed where the size stays the same. Think about your Sutherland Superfan shirt. When you look at that image in the mirror, in other words, it's been reflected, the words are all backwards as opposed to what they were in the original. And that's what makes this an opposite isometry. That's how I remember that the reflection is an opposite isometry. Now, one thing that's interesting about a line reflection is that the distance from any point in the pre-image to the line of reflection is always going to be the same as the distance from its corresponding point in that image to the line of reflection. For instance, if this is my line of reflection, and I want to measure the distance from this point that I'm going to reflect over or across the line, the distance from that point to the line of reflection is going to be the same as the distance from the line of reflection to its image, which I would call A prime. So in other words, you might say that that line of reflection is the bisector or the perpendicular bisector of the segment that connects its point and its image. So what's important here is that under a reflection, not all points in the figure will travel the same distance. That's different than what we looked at with respect to the translation. For instance, a point that's a little bit closer to that line of reflection, like point B, will travel not quite as far as point A, who was further away from that line of reflection. So one important thing to consider is what happens when the point is actually on that line of reflection. If we have a point that's on the line of reflection, such as point C right there, then the pre-image and the image, so C and C prime, would be exactly the same point. That's really interesting to know. Okay, let's go ahead and let's do some line reflections with some points. So to reflect in the x-axis, the notation that we would use for this is we're going to use a lowercase r in order to represent reflection. And we're going to put in subscript right next to that the line over which we're going to reflect. So in other words, a reflection in the x-axis would be notated by doing this lowercase r to represent reflection, and then the subscript x-axis in order to indicate that that's the line that we're reflecting over. Now, anybody that we're going to reflect across the x-axis or the y-axis, because these are perfectly horizontal and vertical line segments, it's going to be very, very easy to use this notion that the point and the image are going to be exactly the same distance from the x or the y-axis, and they're going to be very easy to solve with a graph. So anytime we're reflecting over a horizontal or a vertical line, I would plot these on graph paper and then simply count the distance from the point to the line of reflection, find its image on the opposite side of that line, keeping in mind that the point and its image are the same distance from the line of reflection. So those are going to be very, very, very easily found on a graph. I would use that only for vertical or horizontal lines of reflection. For lines like you see down below, where they're asking you to reflect in the line y equals x and the line y equals negative x, these are going to be a little bit easier to solve by simply memorizing the rule. The rule for reflecting in the line y equals x says to switch both the x and the y coordinates. So again, these two here, I would solve using the rule. And if you think about it, the rule says to do, or the rule says exactly what, or does exactly what the equation says. So the line of reflection here says take y and make it equal to your x, or in other words, take x and make it equal to your y. So say we were taking the point 3, negative 5, and reflecting it in the line whose equation is y equals x. When we switch the x and y coordinates, the point that would map to would be the point whose coordinates are negative 5, 3. To reflect in the line whose equation is y equals negative x, we're both going to switch the x and the y coordinates like we did at the beginning, but in addition to that, we're also going to switch their signs. So it's in order to take that same point with coordinates 3, negative 5, and to reflect that in a line whose equation is y equals negative x, I want to this time not only switch the y and the x, but I want to make or take the opposites of both. So if I take the y value, take its opposite, and make it the x, the new x value is positive 5. To find the new y value, I'm going to take the old x value of 3, take its opposite, so negative 3, and make that my new y. Down at the bottom, it's talking about reflecting in other lines. Well, to reflect the point with coordinates 3, negative 5, and the line whose equation is y equals 3, this line is a perfectly horizontal line. So I would go ahead and I would graph that line. So y equals 3 is going to be that line right there. The point that I want to reflect over that line is the point with coordinates 3, negative 5. So the point 3, negative 5 is exactly 8 units beneath that line. Its image is going to be exactly 8 units above it. So I'm going to call this one A and this one A prime, and its coordinates are 3, 11. And then to reflect the point with coordinates negative 2, 5, so I'm going to go ahead and graph that point. Point B is right there. I want to reflect him in the line whose equation is x equals negative 5. So point B is 3 units to the right of that line. Its image, therefore, would be 3 units to the left. So again, because these points are, or these lines are perfectly vertical and perfectly horizontal lines, I would therefore use the graph in order to find their images. So that's kind of a big idea. If it's a slanted line, use the rule. When it's perfectly horizontal or perfectly vertical, draw the graph and use the graph. All right, as always, thank you for the gift of your time. Flip up to the next page and you can fill in the key ideas and important understandings and see if you can apply what you know to solve the problems on the next page.